Alright, hopefully you grabbed the notes from up there. Fill in what you need to fill in as we go through these notes. Notes fairly short. At the end, the assignment, we'll work on some of that together. So, arcs and chords. Dealing with arcs and chords. And a lot of this we've covered already. The first thing here, if you have two chords that are equal, then the arcs that they cut off have to be equal, and if you have the reverse of that or the converse of it also works. If two arcs are equal, then the chords have to be equal. So if I have this picture and these markings here tell us that these two chords are equal, then that means these two arcs that they cut off have to be equal. So if this arc out here is 72 degrees, then this arc has to be 72 degrees. And if this chord is 12 centimeters, this chord has to be 12 centimeters, so on and so on. Next one, if a radius or a diameter is perpendicular to a chord, then it bisects the chord. So if I have a chord going across this circle here, and I draw a radius, or it could be a diameter, it could go all the way across the circle to that, and it forms a right angle, then it bisects that chord. It splits that chord in half. And notice here, and on some of the problems on the homework, we're going to have to do this. I drew in dotted lines here because we could draw in that triangle, and that triangle is a right triangle. And then once we have a right triangle, we can use Pythagorean theorem, we can use the Pythagorean triples, we can use SOHCAHTOA, so on, so on, so on. Any of those things that help us. And also notice that this segment that I'm drawing in is a radius to the circle. Well, normally they'll tell you the radius or the diameter, so you'll be able to find that length. And this also says that the converse of that works. So if I have a chord in a circle, and I draw a radius going through that chord, and that radius bisects the chord, splits it in half, then it has to form right angles with the chord. Two chords are equidistant from the center point of a circle, then they have to be congruent. So if I have these two chords and the distance, remember the distance has to be given by a right angle there, they have to be perpendicular. So if those two distances are congruent, if they're both the same, if they're both 5 inches or whatever, then these two chords have to be congruent. And then if we go back to the theorem that we just covered, if with this right angle and stuff, we also know that this bisects this chord, it's going to end up bisecting that chord, and this chord over here is going to be bisected. Well, all 4 of those parts are going to be equal to each other, and again, we could draw in right triangles here and right triangles there, and those triangles would be congruent, so we know all that different information. But if the two chords are the same distance from the center, then they have to be congruent. A regular polygon inscribed in a circle. You have a regular polygon inscribed in a circle. This time I used a pentagon. It could be anything. Don't forget this formula that we covered a while back. Remember, N stands for the number of sides. But if this polygon's regular, well, each of these is a chord to the circle, and if they're all congruent, then that means all these all these arcs out here are also congruent. And we could find a whole bunch of stuff about this. The first thing we could find is we could take 360 divided by 5, because we have 5 arcs here. And we end up with, let's see, 5 will go into 367 times, with 1 left over. 5 will go into 10 2 times. So each of these arcs is 72 degrees. The other things we could find if we use this formula, 5 minus 2 times 180, that's 3 times 180. That gives us 540. That means all these angles inside here add up to 540. Well, if they're all the same, then we just take 540 divided by 5. We get 1 there, that's 0, 4, that'd be 0. Bring down the next number, that's 8, that's 40. It comes out even. So each of those angles is 108 degrees. And once we have all that, there's all kinds of stuff we could do if we had the center point here and we drew in this and we drew in this. These two are both radii to the circle, and we probably are going to know that, and they're going to be congruent to each other. All kinds of different things that we could use from that. Just some quick stuff here. Fill in what you need to fill in. Remember, the area of a circle is pi times radius squared. Diameter is always 2 times the radius, and radius is always diameter divided by 2. Circumference is diameter times pi, or circumference is 2 times radius times pi, because diameter is the same as 2 times the radius, so either one of those formulas will work. And remember, when you're doing area and circumference, you might leave your answer if we know the diameter of a circle is 10 centimeters, we might just leave our answer as 10 times pi centimeters for the circumference. Just leave it in terms of pi. That's an exact answer instead of a rounded off answer if we use our calculators. The assignments on page 591, problems 1 through 16. So get your books out and we'll get started on this. If I go too fast, just pause the video. On number 1 through whatever here, they want us to find x. Number 1, we know these two chords are congruent. So that means this arc from here to here and this arc from here to here have to be congruent. Well, we know a whole circle is 360, so I take 360 minus 64, and I get 296. Well, if these two have to be the same, then I just take that 296 and I divide it by 2, and I end up with 148 degrees, and that's our x. That's our answer to number 1. Again, if I go too fast, just pause the video. Number 2. We're looking at this. We know that this chord is congruent to this chord. My picture is not drawn very well. But if those two chords are congruent, then this arc FG and arc DE have to be congruent. So this arc has to be 116 degrees. We're looking for this angle measure. Well, that angle happens to be, and I'm going to separate this off, it happens to be a central angle. That's what we're looking for. Well, we had a theorem that said, or a rule that said, that a central angle and its arc have to be the same. So if this arc is 116, then x has to equal 116 degrees. Number 3, both these chords are 4. That means the arcs that they cut off, arc JK and arc RT, have to be the same. So then arc RT here has to be 82 degrees, and that's our answer. 4. These two chords are the same, they're both 9. That means this arc CA or AC, has to be the same as AB, arc AB. Well, if that's X, then this has to be X. They tell us that this arc is 90. This doesn't help us, but this is an inscribed angle. So if this is 90, we could find this angle, it'd have to be 45 degrees. That's not part of the problem, but we know a whole circle is 360, so I take 360 minus 90. That leaves me with 270. That's for this arc from here to there, and this arc from here to there. Well, we just take 270 and divide it by 2, and that gives us 135. Each one of those arcs is 135 degrees. Number 5 looks like this. These two arcs are congruent, so that means this chord and this chord have to be congruent to each other. So we can just set up the equation. 2x plus 4 has to equal 18. We solve that, we're just solving for x. We end up with 2x equals 14, divide by 2, x equals 7. Number 6, they tell us arc JH is 115, arc IH is 115. So those two arcs are congruent, so that means these two chords have to be congruent. So 5x minus 5 has to equal 2x plus 1. And we just solve that. We get all the x's together first, so I'm going to subtract 2x on both sides. End up with 3x minus 5 equals 1. Add 5 to both sides. Again, if it helps you, draw in those lines there so you keep the two sides separate. These cancel out. You're left with 3x equals 6. Divide by 3. X equals 2. Number 7, chord PM is 6, chord NL is 6, so that means that they're congruent to each other. So it means these two arcs have to be congruent to each other. They tell us one of the arcs is 3x plus 2, and the other arc is 2x plus 4, so they have to be equal. I'm just going to solve those. Subtract 2x on both sides. End up with x plus 2 equals, these cancel out, equals 4. Subtract 2 on both sides. End up, these cancel, x equals 2. That's your answer. Number 8, they tell us the two circles are congruent to each other. So all those same rules apply if the two circles are congruent. So they tell us that this arc is congruent to this arc, which means that these two chords have to be congruent. So 6x has to equal 2x plus 24. Subtract 2x on both sides. End up with 4x equals, these cancel out, equals 24. Divide both sides by 4. And I just end up with x equals 6. If we needed to, if we need to plug back in, we could go back and plug in, see how long these chords are. Probably the easiest place to be right there. You just put in 6 times 6. Well, that's 36, so each chord should be 36 units long, whatever the units are. Number 9, same idea. They tell us that these two circles are congruent. Bad thing is, looking at this, they don't tell us that we have congruent arcs or congruent chords. But if this chord right here, let's say, is 198, then we could find this, or I'm sorry, this arc. Then we could find this arc over here. We just take 360 minus 198, and that comes out to 162. So that arc is 162 degrees. Now we know that arc TU and arc YZ are the same. So that means these two chords have to be the same. So 9x minus 78 has to equal 3x. Ignore that y there. I'm going to subtract 3x on both sides first. Several different ways you could do this. If you do it a different way, that's fine. That leaves me with 6x minus 78. Just a lot of you do this, and I want to make sure you understand. 3x minus 3x leaves you with 0 on that side. Don't let that confuse you. Now we add 78 to both sides. We end up with 6x equals 78. Then we divide both sides by 6. And you end up with x equals 13. Uh, 10, 11, and 12 all use the same picture. It says in circle P, PQ, which is a radius to the circle, is 13. That's a radius. I'm going to write that up here so I don't forget it. And RS is 24. Well, if this is a radius and this is a chord and it forms a right angle right here, then it has to bisect it. So RT has to be 12 and TS has to be 12. So I'm going to write that in. And that's one of our answers. RT right here is 12. Then the other thing that we can do, I'm going to draw in this. That's a radius to the circle, but it also forms a right triangle right there. And I know that that radius is 13. So now I have this right triangle. That's a right angle. This is T, this is R, this is P. This part right here is 12, this part's 13. And we want to find PT. We want to find this. Well, we can use Pythagorean's theorem. A squared plus B squared equals C squared. This actually fits one of the triples. If you can remember which triple it fits, then you can just use that. I'm going to make that A. So that's a leg. I don't know it. The other leg is 12. Remember, always find the hypotenuse there. 13 squared. 12 squared is 144. 13 squared is 169. Subtract 144 on both sides. You end up with, these cancel out. A squared equals 25. Take the square root of both sides. You end up with A equals 5. So segment PT right here is 5. And then they want you to find TQ. Well, from P to Q, if I split that off, P to Q, that whole thing is 13. That's a radius. T is right here somewhere. P to T is 5. All we got to do to find this part is subtract 13 minus 5, which gives us 8. So TQ is 8. Next one, in circle A, EB, which is a diameter, is 12. CD, this chord is 8. And CD is 90 degrees. Or I'm sorry, arc CD, that's an arc symbol. Arc CD is 90 degrees. Same idea on this one. If EB is 12, then that means the radius is 6. So I'll probably use that at some point. CD here, this chord is 8, and it forms a right angle right there, and so it has to be bisected. So that part has to be 4, that part has to be 4. If I draw in this radius, it's 6. So we have a right triangle there. Right angle there. This is A, this is F, this is C, this is 6, this part's 4. We can find AF by using Pythagorean theorem. And AF is the very last thing they ask us to find. They want us to find the measure of arc DE. Well, arc DE is from here to there. If it bisects this chord, then it also bisects this arc. So all we got to do is take half of that, and we get 45 degrees for that. FD we already found, that's 4. Several different ways we could find AF. Again, we could use Pythagorean theorem, and that's what I'm going to do here. But we could also look at this angle right here. This arc is 45 degrees from here to here. That means that angle has to be 45 degrees. And if that angle's 45 degrees right here, all right, sorry, I don't think whoever wrote the book completely thought this problem through, because I don't think the numbers quite match up. But we'll just use Pythagorean theorem. We'll call this A. AF there is A, so A squared plus B squared, which is the other leg, 4 squared equals 6 squared, which is the hypotenuse over here. That's A squared plus 16 equals 36. Subtract 16 on both sides. A squared equals 20. Take the square root of both sides. Square root of 20. Grab your calculator. Square root 20. And I end up with 4 point, what did it say there? I think it said round your answers off to the nearest hundredth. So 2 places, 4.47. The last one says, for security purposes, a jewelry company prints a hidden watermark on the logo of its official documents. A watermark, if you look at money and you hold it up to the light, you can sort of see that it has things sort of in the background that look like they're in the background. Those are watermarks so that you can't fake it. Watermark is a chord located 0.7 centimeters from the center of a circular ring that has a 2.5 centimeter radius. It's the nearest tenth. What is the length of the chord? So I'm just going to draw myself a picture here. We got this ring, and we'll put a center in it, and we have some chord runs from one side to another. It's located 0.7 centimeters from the center, so from here to there is 0.7 centimeters, and it has a radius of 2.5 centimeters, so from here to here will be 2.5 centimeters. And we want to figure out how long, and this has to be a right angle there if that's a distance. We want to figure out how long this chord is. Well, if that's a right angle, this has to be bisected. So if we find this part, we can just double that to get the whole thing. So we have another right triangle there. This is 0.7. This is 2.5, and again, I'm just going to use Pythagorean's theorem. This actually fits one of the triples. So if you see that it fits one of the triples, you can use that. Otherwise, it's Pythagorean's theorem. So a squared plus 0.7 squared equals 2.5 squared. A squared equals 0.49. That's 7 squared, and then 2.5 squared is 6.25. That should be a plus there, not an equal sign. Subtract off 0.49 on both sides. And I end up with a squared equals 5.76. And then you want to take the square root of that, so second square root 5.76, and I end up with a equals 2.4. So this part right here is 2.4 centimeters. Well, that's not our answer. That's this half of that chord. The other half is 2.4. So we want 2.4 plus 2.4, which is 4.8 centimeters. That's how long the chord is.